Hello, everyone. Welcome to How to Build and Train Custom Models on Vertex AI. My name is Sarah Robinson. I'm a developer advocate on the cloud team focused on machine learning. As a developer advocate, my job is to educate and inspire external developers, data scientists, ML engineers, and teach them how to use all the different machine learning products that we offer on Google Cloud. Another important part of the job is bringing feedback from the external community back to our product teams. And you can find me on Twitter at srobtweets. So what am I going to cover in this presentation? I'll start by introducing you to Vertex AI and talking about all the different model training tools that we offer. Then we'll look at some tools we can use to explore data and start prototyping models. And then we'll dive into two different model training options that are offered on Vertex AI, both AutoML and running your own custom model code. I'll end with a demo. So let's dive right in to model training tools. First off, what is Vertex AI? Vertex AI provides tools to support your end-to-end machine learning workflow, all the way from gathering your data to training models, to deploying those models and managing those deployed models in production. It supports different model types and varying levels of ML expertise. So whether you're new to ML or have a lot of experience building custom machine learning models, Vertex AI has tools to help you out. What are these tools? We can see all the different parts of Vertex AI here. As I mentioned, these tools are designed to support an entire machine learning workflow, from gathering data to training and tuning your models, serving, and monitoring those deployed models. In this section, I'm going to be focused entirely on the tools for model training. So we'll be looking at the tools that are highlighted here. When I'm talking to teams that want to use machine learning to solve a particular task, I usually start by going through this simple decision flowchart. So the first question I ask is if they have their own training data that they want to use to solve this problem. If the answer is no, we have a set of pre-trained APIs that we provide on Google Cloud that give you access to machine learning models that have already been trained on lots and lots of data to accomplish common tasks like analyzing images or text. And you can access these with a simple REST API call. For this presentation, I'm going to be focused on the right side of this flowchart. So I'm going to assume that you do have your own training data and you want to use that to train a model on a custom task. The next question to think about is whether you're going to write that model code yourself. If the answer is no, we have a tool called AutoML, which lets you train custom models without requiring you to write any model code at all. If you do want to write the model code yourself using popular open source machine learning frameworks, we have tooling to run training jobs and deploy those models on Vertex AI. So the takeaway here is whether or not you're writing model code yourself, we can support you on Vertex AI, and I'll show you how throughout this presentation. All of the tools that I'm going to be covering support both UI-based and programmatic model development using the Vertex AI SDK. So just keep in mind that if I'm showing you how to do something in the UI, there's also an API method for doing that programmatically. So let's dive into the next section where we'll look at some tools for exploring data and prototyping machine learning models. For this, we're going to use Vertex Notebooks. This is a hosted JupyterLab notebook solution where you can create notebook instances that come with your favorite data science and machine learning frameworks pre-installed. You can also install additional libraries once you've created an instance. You can customize the size of that instance and the hardware, so you can do things like add GPUs to a notebook instance. It also integrates directly with Git, so you can initialize a Git repository in your notebook, and it integrates well with other Google Cloud services. So a little bit more detail on what that Git integration looks like. You can stage your commits right in the notebook's UI, or you can do it via the terminal in your notebook. It also provides a nice diffing tool. And how can you use these notebooks for exploratory data analysis? So in this example, we're taking a data set that we have in BigQuery. BigQuery is Google Cloud's enterprise data warehouse. So we have some of our data in BigQuery in the same project where we've created this notebook instance. Using the BigQuery client library right in our notebook, we can download that BigQuery data set as a pandas data frame, and we can start to do some data analysis before we prepare this data for training a model. So once you've figured out what data set you want to use and how to frame that data as features for your model, The next step is thinking about how to run that training job on Vertex AI. And one way you can do that is through our Vertex AI Python SDK. With the SDK, you can build end-to-end machine learning workflows in Python. You can use the SDK methods to create data sets, training jobs, deploy your model to endpoints, get predictions, and even more that's not covered here. So in this code snippet, we're using the SDK to create a tabular data set and then run a model training job with AutoML on that data set. So once you're ready to train a model, the next step is uploading that data to Vertex AI. And one option for that is using Vertex's managed dataset service. So to do this, you just need to select the type of data that you're working with. Could be image, tabular, text, or video data. And then you need to choose the prediction task that you're solving with that data. If your use case doesn't fall into any of these prediction tasks, don't worry, you can still train and serve your models on Vertex AI. This is just one option for uploading your data. So to zoom out a little bit and see at a high level where this fits into an end-to-end machine learning workflow, you would upload your data via managed datasets or bring your own dataset. The next step is to think about the approach you want to use for training your model, whether you want to use AutoML or your own custom model code. After that, you would deploy your model. There's various options for model deployment on Vertex AI. We're not going to cover that in this session, but there is another session that I definitely recommend checking out that covers model deployment on Vertex AI. So let's start by looking at how you would use AutoML for training your model. So now we'll look at AutoML on Vertex AI. What AutoML training provides is it gives you access to state-of-the-art machine learning models without requiring you to write any model code at all. So you upload your data, you select one of the prediction tasks that I showed on a previous slide, and then all you do is press a train button. AutoML will find the best model architecture for your prediction task, and then once your model is done training, you get access to detailed model evaluation metrics to see how your model performed on the test data. And you also get feature attributions, which tell you which features your model relied on most to make its predictions, to give you a little bit more transparency on how your model is working under the hood. This is powered by explainable AI. So AutoML gives you access to really high quality machine learning models. And how does this work? Under the hood, this is powered by the latest research from Google Brain. So AutoML is taking care of all the different steps you see here without you having to worry about them at all. So in the first phase, it's going to do some data transformation and pre-processing for you. It'll take your raw data and transform that data into the format that your model needs. It'll then use a technique called neural architecture search to search various model architectures and find the one or ones that are optimal for your prediction task. It'll then ensemble different model architectures together and prepare your model to export it so that it can be used to make predictions. So you get access to all of this just by pressing a train button in AutoML. There are, though, many cases where you'd want to write your own custom model code. And next, I'm going to show you how you can take your own model code and use it to run training and accelerate your training workloads on Vertex AI. So if you want to take model code that you've written yourself, you have two options for training that on Vertex AI. First, you can use a pre-built container. So to do that, you would package up your training code as a Python package, and then choose one of the pre-built containers that we offer. These support TensorFlow, scikit-learn, XGBoost, or PyTorch. If your model training code doesn't quite fall into one of those frameworks, or you want to use a different version, you can package up your training code as in a Docker container and then push that container to Google Container Registry and point Vertex AI to that container image and run training that way. So once you've decided whether you want to use pre-built or custom containers, you can take advantage of some of the other configuration options that Vertex AI provides for training. So you can run distributed training jobs. You can also accelerate those training jobs with GPUs. And finally, you can use Vertex AI for hyperparameter tuning. Let's take a look at these functionalities in a bit more detail. So how does scaling your training jobs work on Vertex AI? So all you need to do if you want to run distributed training on Vertex AI is make sure that your training code specifies a distribution strategy. Then when you write the code to kick off a training job, you need to specify the number of replicas or machines that you want Vertex AI to distribute your training job between. In this case, we're using 4. Then you would specify the machine type for those and whether or not you'd like to accelerate those machines with something like a GPU. In this case, we're using an NVIDIA GPU. So you can do this either programmatically, as I'm showing here, or via the UI in the Vertex AI console. Another feature that you can make use of on Vertex AI to accelerate your training jobs is hyperparameter tuning. You can have Vertex AI find the optimal values for different hyperparameters in your model training task. You can choose from 3 different hyperparameter tuning algorithms, including Bayesian optimization. All you need to do is provide a config file or set this up in the UI, tell Vertex AI the different hyperparameters that you want to tune, the range of values you want it to try, and finally, the metric that you're optimizing for. In this case, we're tuning 2 different hyperparameters, learning rate and the number of neurons in the first layer of our neural network. We want Vertex AI to optimize for our validation loss or error, and we want it to minimize this error. So in this case, we're running 10 different trials, and we're running at most 2 trials in parallel. So once we kick off this training job, we can see in the console the hyperparameter values that Vertex AI has chosen for each trial and the resulting value for that metric that we're trying to optimize for. So a lot of times when I talk about these 2 different training options, AutoML or custom model code, folks have questions about whether or not they should write their own model code or not. So as with most things in machine learning, the answer is that it depends. But I've put together this table to help you weigh some of the trade-offs in this consideration. So first, if your use case fits into one of the supported AutoML offerings that I introduced when I talked about managed datasets, then AutoML can be a great choice. If your use case doesn't fit into any of those prediction tasks, then you'll want to write your own custom model code. So an example of this might be if you have a model that takes both images and tabular metadata on those images to produce a classification output. In that case, where you're dealing with mixed input types, you'll want to write your own custom model code. If your use case doesn't require that you know specifics about your underlying model, like the architecture that was chosen, AutoML is a great choice. And you can build a custom model if you need more control over your model's architecture or the machine learning framework that was used to build it. And finally, if you want to develop a quick initial model to use as a baseline, AutoML can be great for quick prototyping, and this model that you produce could very well end up being your production model. On the other hand, if you already have a baseline or heuristic benchmark and you want to see if you can improve upon it, then writing your own custom model code could be the way to go. So now that we've seen an introduction to all the different training options available on Vertex AI, let's dive into a demo. So in this demo, I'm going to show you how to explore data and do some model prototyping in notebooks. We'll be grabbing data that we have in a data set in BigQuery. Then I'll show you how to use the Vertex AI SDK to start different training jobs. And finally, we will monitor those training jobs in the Vertex AI console. So let's go into the demo. Here we are in the Vertex AI console, and the first thing we're going to do is some exploratory data analysis using notebooks. With notebooks, we can create a hosted JupyterLab notebook. So if we click on New Instance here, we can see that there's many different types of notebooks to choose from that come pre-installed with your favorite data science and machine learning frameworks. And you can also install additional libraries once you've created the instance. You can customize the size of your instance, and you can even add GPUs. Here I'm going to use a notebook I've already created, so let's open it up. We'll be using this notebook to download our data, do some data analysis, and kick off training jobs. First, let's familiarize ourselves with the data that we're going to be using for this. This data set is originally from UCI Machine Learning. This data was taken from images of different types of beans, and what we have is a tabular data set with many different data points on each type of bean. I've loaded this data set into BigQuery. Here we can see the data schema, which includes many different data points, all numerical data on these beans. And the label, the thing we're predicting, is called class. And so we can run a quick query on this table to see roughly what the distribution is for the different bean types across the data set. So now let's see how we can analyze this data in a notebook. I can use the BigQuery client library right in my notebook. And what I'll do is I will download that data set that I just showed you in BigQuery into this notebook as a pandas data frame. So using this pandas method, we can see a plot of how the data is distributed by parameter. Next, we're going to use the Seaborn library to create a pair plot. And this can help us identify relationships between different features in our data and the label column, which is the class. So now that we have a good idea of what our data looks like and how it's balanced, we're ready to think about kicking off a training job in Vertex AI. Next, I want to initialize the Vertex AI SDK. In this demo, I want to show you two training methods that I discussed earlier. In order to run a training job with AutoML, I need to first create a data set. I can do that by passing it the URL of the data in BigQuery, which is what I showed you earlier. So now if we go over to our Vertex AI console under Datasets and refresh this page, we should see the dataset that I just created. There it is. If we click on it, we can see more details about the features. So we can see the data source in BigQuery. We can also see all of the different columns in our dataset. We could kick off a training job here, but I want to show you how to do that using the Vertex AI SDK. So let's go back to the notebook. So here's the code to create a training job. I tell it the type of model. This is going to be a classification model because we're going to be classifying these examples into the 7 different types of beans. And I just need to pass it all the different features that I want to use in training this model. So I'll run this to set up the training job. There are other options here that I'm not including, which you can use to tell AutoML what you'd like to optimize for during training. This is useful if you have an especially imbalanced data set. Finally, this job.run snippet is the code we need to kick off that training job in AutoML. We tell it the data set we want it to use, the label or target column, the thing we're predicting, how long we want it to run training for. Finally, we'd like to enable early stopping, which means that if Vertex AI is not able to find a better model for us, it'll stop the training job and will only be charged for the training time that was used. So let's kick off this training job. And if we go to our console, we can take a look at that. And we can see that this data set now has a training job associated with it. So we can see some metadata on our training job. This will be updated as training continues. And when training completes, we'll be able to see some evaluation metrics on the resulting trained model. Our AutoML training job has now finished, and we can look at various evaluation metrics to see how our model performed. Looking at the confusion matrix, we can see how our model performed across the test set for each class in our data. Looks like our model was able to do a pretty good job at distinguishing between these different types of beans. For models trained on tabular data, Vertex AI gives us feature importance out of the box with AutoML. So here we can see the features in our dataset that signaled our model's prediction the most. For our test dataset, it looks like shape and eccentricity were most important to our model when classifying these beans. We could then take this model and run batch predictions on it, deploy it to an endpoint for online prediction, or even download the model in a Docker container to run it offline. Now that we've seen how to kick off an AutoML training job, let's see how we might train a model on this dataset using our own custom model code. Back in our notebook, I've built a TensorFlow model to do classification on the same dataset. I've taken that TensorFlow model code and packaged it up into a Docker container, which we can see here. I've pushed this containerized code to Google Container Registry, and we can see the image here. Now that this is in Google Container Registry, I can point Vertex AI at this container image when I run training. For this particular training job, I've added a distribution strategy to my TensorFlow training code because I want to take advantage of distributed training. To set up this job, I tell Vertex AI the URL of that container in Google Container Registry. I'm also going to use a pre-built container when I deploy this model later for prediction. As I mentioned, I want to use distributed training here. For this example, I'm going to distribute my training job across 5 different machines, which is why I've specified replica count equals 5 here. I also need to tell Vertex the machine type I want to use for each of those machines, and in this case, I would like to add a GPU accelerator to each of those replicas, which I've specified here. Let's kick off this job. Now, if we go to the training section of our console in Vertex AI, we can see the status of our training job. Here we can see that we have 2 worker pools. The first contains our primary replica, and the other worker pool contains the 4 other machines. Notice that this is using the machine type that we specified, N1 standard 4, and each machine has an associated GPU. Here we can look at the logs for our custom job. We can see that training completed successfully. We can also see that our TensorFlow saved model was written to the cloud storage location that we specified. From here, we could download the model and serve it on device, create a model to get batch predictions, or deploy it to an endpoint for online prediction. To learn more about the training tools on Vertex AI that I covered in this session, check out the links on this slide for step-by-step tutorials and links to dive into the documentation. Thanks for watching.